Okay, so in this next segment, I am going to show you how to calculate a correlation coefficient. And this is just to show you how simple it really is. And this way you'll know exactly what SPSS is doing behind the scenes whenever we run one of these. And it just will demystify the process for us. So here's the formula for R, and we have on the numerator the sum of the cross products, which is given below in the smaller box. And then on the denominator of that formula, we have the square root of the product of the sum of squares for both x and y. So moving on to the next slide here, we have an Excel sheet embedded, and so remember to make it bigger. We left click and then right click until this menu comes up, and we'll select Worksheet Object and then Open, and that should open this screen for us. We have a hypothetical scenario here. We have two experts, in this case managers, rating the performance of an employee. And we have 5 employees, and we have first manager ratings, manager X ratings, and manager Y ratings for each one. We could also imagine a similar scenario where we have a client or a patient, and we have a psychiatrist, 2 of them rating each patient to determine what diagnosis they should have in order to get treatment. So a lot of times what we do in psychology is we calculate this thing called inter-rater reliability coefficient. And that's basically where we would just correlate manager X ratings with manager Y, and we hope that there's a strong and positive correlation between those two. And this just indicates, at the most basic level, that manager X and manager Y are both coming from the same frame of reference when they're looking at each employee. So the underlying theory of this is that we hope that there's consistency between the 2 managers when they're rating each one. So if employee 2, for example, is the best out of all of them, which in this case they're not, but let's just say that they are, we would hope that manager X and Y both rate that employee better than all the rest. And so that's what we're looking for here when we're calculating a reliability coefficient. Okay, so to start us off, let's calculate some things first. We have sum and mean and standard deviation. So I don't think the sum and standard deviation are that important, but I want to just calculate them for you so that you can see how the process is done and how Excel works in case you're unfamiliar. Okay, so let's put the sum of manager X ratings in this box right here. It's B10, and the way we calculate that is we do equals sum, and then we indicate the cells that we want summed together. So we have B3 through B7, and we indicate that by doing B3, and then through is indicated by a colon, B7, close parentheses, and hit enter. So we can see manager X ratings, the sum of those is 25. We're going to do the same thing for manager Y. Remember, equals sum, parentheses, and we can go straight to the cells that we want to sum together and click and drag across them. As you can see, C3 through C7 this time, close parentheses, and enter. For mean, it's the same process, except we're going to do an equals average. That's the command that will give us our mean. Click and drag again, B3 through B7. Same here. And we definitely don't need the standard deviation, but I just want to show you how to calculate it anyway. It's equals, I believe it's STDEV. Same process. STDEV. Okay, so those we have the basic information here then that for the manager X and Y ratings, and we need some more information, and that's given in these columns here. First, we want to calculate the deviations for X from manager X's mean, which is 5, and likewise the deviations for manager Y from his or her mean, which is 3.4. Okay, so to calculate these, we want to have, in this case, 9 minus 5 for this one, 2 minus 5 for here, and so on down the line. So we're going to do an equals, and we're going to indicate the cell that we want, which is B3 in this case. Oops. B3 minus, and then we have 5 down here, which is the mean. So we're just going to put 5 because we want that to stay uniform down the column. So B3 minus 5 is 4. Obviously, 9 minus 5 is 4. And to copy and calculate that formula all the way down, we'll do a Control C, and then click and drag all the way down, and then do a Control V, which is paste. So it's just a copy paste, and that should do it. Just to give us a quick check, we can highlight the cells, and we can see down here that their sum is 0. Remember, as we learned before, always with these deviation scores, they're going to sum to 0, so that's why we square them. But we're not going to square them just yet. All right, so we're going to do y minus the mean of y. And so we have manager y. The first rating is 4, and we're going to subtract 3.4 from that, and so on down the line. So we're going to do equals. This time it's C3 minus 3.4 is manager y's mean, and then we're going to copy, Control C, and then drag and Control V, and there we have our deviations for y. And we can highlight those and see again that their sum is 0. Now for the cross products. We're going to calculate the cross products on down, and that is just going to be D3 times E3, D4, excuse me, times E4, and on down the line. So we're going to do an equals here, and we're going to start with D3, and times is the star in Excel, and we're going to multiply that by E3, and then we're going to hit enter. And that's 2.4, and we're going to do a Control C and Control V, and those are all of our cross products, which is awesome. And we can do a sum of those later. Okay, now we're going to do our sum of squares, which is the denominator of our formula, recall, but we need to calculate those. And what we do is we just take the x deviations, which is this column right here, and we're going to square those. So we're going to do equals D3, and then to square something in Excel, you do a caret, which is the shift and 6. And then do it to the power of 2. So to square something, we're going to raise D3 to the power of 2 and hit enter. And then we're going to copy and paste that one down. And that's going to give us all of the squared deviations for x. And we'll sum those up later. Same with the y deviations. We're going to square those. So we're going to do equals. This time we have the cell E3. Caret, raise it to the power of 2. And we're going to copy that on down and paste. Okay, so we have most of the preliminary information in order to calculate R. We just need to sum some things together. So remember, we already summed these things. So all we need to do is do a Control C on this cell and then copy it across, and it will calculate sums for all of those columns. So cool. Just in case we want to do means, we can do the same thing. I don't think we need the means, but just to show you that it can be done. Okay, so now we have all the information for our R formula. And so just go click into a cell that is currently unoccupied, like this one. And we're going to do an equals, and then we're going to do the numerator of our R formula, which was the sum of the cross products. And that is this cell right here. It's 4.8, but we'll just name the cell, and that is, up here, the sum of the cross products, not the mean. So this is F10, and it's 24, but we'll refer to it as F10. You can also type in 24. It will do the same thing. So we're going to say equals F10, so that box there that's highlighted. And then we will do a divide, and we'll do our denominator. So our denominator is going to be the sum of the the product of the sums of squares. And that is these two things right here. It's the G10 and H10, 50 and 21.2. So we're going to put some parentheses just to set it off, and we're going to do G10 times the star, remember, H10, close parentheses, and now we're going to have to square root this thing. And the way we do that in Excel is do raising to the power of 0.5. Okay, so raising to the power of 2 squares, raising to the power of 0.5 does the square root. Okay, so that's our formula, and we just hit enter, and we have a correlation of 0.737 and some other things at the end. But basically, that's a nice healthy correlation between the manager's ratings. So we would go and report the finding that they were consistent with one another in how they viewed the employees. Now, just to check our work, Excel also does a quick correlation. So what you can do is just go into another vacant cell and do equals, and the command in Excel for this is CORREL. So do that and then parentheses, and then highlight the X values that we want, and then separate them with a comma, and then the Y values. And then close parentheses and hit enter, and there we have our verification that we did it right. So 0.737 or 0.74, that means that there was a fairly high correlation. Usually for inter-rater reliability, we're happy with 0.7 and up. Of course, higher is always better, but for this, we can say that there was a pretty healthy correlation between the two. So that is how you calculate a correlation coefficient. You can do this anytime in Excel. In fact, you can use the same template and just simply substitute some different numbers in here for X and Y in these columns here, and do this anytime you want to refresh your memory on how to calculate R.